All right, so here's what I'm going to ask you to do. I want you all to measure the length of your table, and you can have your table partner help you. If you don't have a table partner, you can partner with someone else. Measure the length of your table, but you're not allowed to use a ruler. Actually, let me say this. Measure the length of your table using pencils. Ready, set, go. Measure the length of your table in pencils. Ready, set, go. Measure the length of your table in pencils. And we are measuring the length of the table in pencils. Yes, you and your partner decide how you want to do that. Measure the length of the table in pencils. All right, so we're going to jot down our measurements here. Now, would you all agree that all the tables you're sitting at are the same? Okay. So we have table lengths. Table lengths. Joe, what was the length of your table? 9 3/4. And your units were? Pencils. 9 3/4 pencil. All right. Emily, what about your table? 8. And did you use the same unit? Pencil? Okay. Just confirming here. Morgan, what about your table? 10. I hear that right? And you also use pencil? Okay. 10 pencil. All right. And you worked with Haley, right? Okay. So what about Alexis? What about you, Rebecca? 8. So we have 8 pencil. Okay. Very good. Dalton, what about yours?
8 unused pencils.
8, but still pencil, right? 8 pencil. All right. Tara, what about yours? 8? 8 pencil. Okay. What about Maddie's? 8 as well. All right, we already got Joe. Karen, Miss Garcia, what about your table?
8-ish. 8, and we need like half of one.
8 and a half. Jolie, what about your table? 10 pencil. Emma, what about your table? 8 and 1/3. All right, so here's the deal, folks. You all told me that you agreed that your tables were the same. Yet, we have 1, 2, 3, 4, 5 different measurements. That means y'all don't know how to measure, right?
No.
We have different pencils.
Different pencils.
We'll get there. I know. All right, now I want you to do this. I want you to measure the width of this room from that wall to that wall using your shoe. Ready, set, go. I want you to measure it in shoes.
Okay,
You do it how you want. You do it how you want. Measure the width of the room from wall to wall in shoes. But yeah, you can't. It's going to be that wall though.
Okay, 4.
So measure the width of the room in shoe. So I'll turn the camera around here and you can see what your classmates are doing here.
I'm the same size feet as Jose. You are size 8.
Once you have figured your measurement out, you may take a seat. Once you have figured your measurement out, you may take a seat. your mask over your face and your nose. It makes absolutely zero sense to leave it on, and then when you go to talk to someone, didn't take it off. That's exactly when you should be wearing it, right? That's when you're spewing out particles and all that stuff. So please leave it over your face and nose. All right, let's hear our results of the room width. And again, you all measured the width using the same unit, shoe. Let's start in the back this time. Riley, what did you and Emma get, ma'am? 33 and what? 33 and a half shoe. 33 and 1/2 shoe. All right, we'll work our way up now. Garrett, you and Jolie.
27 and 1/4.
27 and a quarter. Now, if you measured it separately from your table partner, I can take that measurement too. Joe, did you measure it separately? No? Emma, did you measure it separately? Okay. So if you have different measurements, that's fine. What about Kara and Miss Garcia? 29 shoe. 29 shoe. All right, what about Joe and Donnie? 30 shoe. All right, what about Makuya and Emily? 33 shoe. Man, we have 5 different measurements for 5 different groups so far. Elena's group. 31 and a quarter shoes. What about Tiara? 32 and a half shoe. All right, what about Isabel's group? 31 shoe. Again, there are no 2 that are the same. Oh my gosh. What about Becca's group? 32. Again, no 2 that are the same. All right, Haley and Morgan, what'd you get? 31. And wow, that's 1 set was the same. All right, now I know you guys know why these aren't the same. What point do you think I am trying to make here? Okay, you all measured the same room. You all measured the same table. You all used a pencil and you all used a shoe. Yet you get different measurements. This one.
Not all measurements are the same, correct?
Okay, very good. I like that. Ms. Peyton.
It'd be a controlled variable.
Okay, you're talking about a control. Yeah, I can tell you want to say that. You side. Maddie stole your thunder. Wanted to relate that stuff we had learned. Yeah, you can dab. That's okay. That's good stuff. That's good. Cam Newton's back in the league. You know, he started for the Patriots. Anyway, okay. Here is the point, ladies and gentlemen. Is a unit of measurement any good if there is not some agreed upon standard for what it means? Does it do us any good to measure the length of the table in pencils if there is not one agreed upon standard for how long a pencil is? It doesn't do us any good, does it? Here's the thing. In the history of measurement and science, and they kind of go hand in hand, for a long time, the scientific community had to deal with this right here. To put it into modern times, it would be like if in Iowa a foot was this long, and then you go to Minnesota and a foot is this long, and then you go to Wisconsin and a foot's this long, and you go to Illinois and a foot's this long. That's what it was like, trying to measure things and communicate in science. If you don't have a standard way to measure, what do I mean by standard? I've used that word a few times. What do we mean by a standard way? Any thoughts there? A standard way. Dalton? One way? Okay. Is there just one way? Or is there just one single unit to measure the length of something? There's not, but to Dalton's point, what would have been a better way to measure the width of the room, guys? You guys tell me. Okay, tape measure and use what sort of unit, Dottie? Okay, could you have measured the width of the room in inches? And would you all have gotten the same answer? If you all got a measure, then the answer would be yes, you would get the same thing. Because we have an agreed upon amount for what an inch is, right? Likewise, if you all would have measured it in meters, would you have gotten the same thing? Or feet. or yards, or centimeters, or miles, or kilometers, you would have got the same thing. Okay? Those are all agreed upon amounts for a measurement. Which leads us to a definition for a unit of measurement. It is actually already written up here. I will circle it so you all can pay attention to it. And because I have written it down on the board, what should you do? You all should write it down too. Please write it down, yes. So a unit of measurement is an agreed upon value for measuring a quantity. An agreed upon value for measuring a quantity. An agreed upon value for measuring a quantity. So the problem that we were having, that you all experienced, and yes, I knew you would know this, and I knew we obviously knew they would be different. But when you were measuring the length of your table in pencils, when you were measuring the width of the room in shoes, we did not have one single agreed upon value for what that quantity was. There is no one single shoe length that we were using, was there? Now, what if I had said, I want you to measure the width of this room using Dottie's right shoe? Then could you all have an agreed upon measurement? Yeah. Then you could have. You could have. Or if I had said, measure the width of your table using Maddie's pencil. As long as she doesn't sharpen it in between measurements, right? Then we'd have a problem. Did anyone ever use pencils that you sharpen down to where like that long or I never like that. If it's not long enough to go all the way through my hand, I can't do it. I can't. When I write, not so much on the board, my handwriting isn't great on the board, but if I'm just writing on a piece of paper, I like to have very precise handwriting. If the pencil isn't long enough, I can't do it. Not good. Okay. So, what sorts of units do you think we will use in this class? What sorts of units do you think we'll use in this class? Will we use shoes and pencils? No, not all. What do you think would be some units for length that we will use in this class?
Feet.
I heard feet. Emma, what do you want to say? Inches. I heard centimeters. Meters. In the scientific community, how science is done worldwide, what sorts of units get used? Metric. We will use, whenever possible, which is basically always, we will use metric. Now, I know that none of you are very familiar with the metric system, and that's not your fault. It's not your fault. And it's not your previous teacher's fault. It's not your parents' fault. Just the country we live in, our standard measurement is not metric, is it? Okay? Back in the late 70s and early 80s, there was a push in this country to get us to use the metric system. Now, I say that not from experience. I'm not that old. I was not born until 1984, so I didn't experience this as it happened. Tell me, how successful were we in getting to the metric system? Yeah, not at all, because you all don't hardly know it. Again, not your fault, okay? We just don't use it in this country. Here's what was attempted to try to get Americans to use the metric system. You ever notice, like when you buy a bottle of pop or a bottle of Gatorade, you know, it'll tell you how many ounces it is. If you buy a standard can of pop, how many ounces is it? You guys know? 12. 12 ounces in a standard can. Did you say that, Joey? Okay. 12 ounces. It says right on 12 fluid ounces. Have you also noticed that next to parentheses, it will tell you what? It will tell you how many milliliters it is. How many of you pay attention to that? Exactly. A lot of you don't even know it's there. You don't even notice it. That's basically how it was attempted to get Americans to take on the metric system. They tried to label things with both. Well, what happens is you don't even pay attention to the one that you're not familiar with. Okay? If I was put in charge of getting this country to the metric system, if I could do anything I wanted and pass any laws I wanted to, this would be the fastest way to do it in my opinion. You guys tell me if you agree with me. I would make it mandatory, make it law, that any labeling on food items, it had to be metric. Let's start with that. So when you go buy a can of pop, it's not going to say 12 fluid ounces. It's going to say 355 milliliters. That's how many milliliters are in 12 ounces. When you're driving down the road, it's not going to tell you how many miles it is to Forest City. It's going to tell you how many kilometers it is. Any advertisements, labels, anything you see on television must all be in metric. The speedometers in your cars will no longer read miles per hour, they will only read kilometers per hour. When you watch a weather forecast, it will no longer be in degrees Fahrenheit, it will be in degrees Celsius. Here's the thing, if I told you, now this is not going to be the case, but if I told you tomorrow's temperature is going to be 95 degrees Fahrenheit, it's not, I'm lying to you, but if I told you that, you all would have a very clear understanding of how hot that was, right? If I told you tomorrow was going to be 32 degrees Celsius, that would have almost no meaning to a lot of us, would it? But think about this. If instantly, if every time you looked at your phone to look at the temperature, if it was in Celsius, how long would it take you to get used to it? No. This thing, if you went outside right now, okay, and I told you, I don't know what it is, I'm going to estimate, I'm going to say it's roughly 18 degrees Celsius. Okay? And then tomorrow you went out, it's a little warmer, and I told you it's 22 degrees Celsius. It's not going to take you very long to start to ingrain what that feels like. It just won't. Your brains are incredibly powerful. Now, at first, what's going to happen, and this is the same thing that happens whenever you learn a new language, is your brain, you will always say, okay, well what does that mean in Fahrenheit? Right? That's what your brain will start doing. It's like when you're learning a new language, like right now I'm taking Spanish class, everything you say in here, you're always thinking, well, what does that mean in English, right? Okay? Eventually, though, you get to a point when you don't have to think that way anymore. You do. You get to a point when you don't have to think that way anymore. And it would happen really fast, guys. Okay? If this country wanted to do that, it would not take us that long to get it figured out. Okay? Would people be hesitant? Would they resist? Yeah, they would. Okay? Yes, ma'am?
How hot is 100 degrees Celsius?
100 degrees Celsius is 212 degrees Fahrenheit. That is the boiling point of water. So if you want boiling water for it, honey?
No.
Yeah, that would be severe burns. 100 degrees
But
Celsius.
Celsius would make more sense though because it starts at 0.
Well, be careful. It doesn't start at 0. That's the
Well, like,
freezing.
that's
It's the freezing point
But
of
then
water.
in Fahrenheit it starts at 32.
The
so that's
freezing
kind of
point
weird.
of water is 32 degrees Fahrenheit. Yes. Yes, Julie.
So if it's like 20 degrees Fahrenheit.
20 degrees Fahrenheit. That'd be cold.
Yes, what's it in Celsius?
Oh, that'd be like negative
So it's-
8.
so it's-
Negative 8 degrees Celsius. Something like that.
What do you get when you get into the negatives of Fahrenheit?
Really, really cold.
In Celsius, like, how do you get
Well, like,
Still nice.
Oh.
there is one value on the Fahrenheit and Celsius scale that's actually the same. Because they overlap. A Celsius degree is larger than a Fahrenheit degree. And so as you work up and you work down, there's one point where they have to be the same. It's at negative 40 degrees. Negative 40 degrees Fahrenheit is the same thing as negative 40 degrees Celsius. They're the same temperature. But because a Celsius degree is bigger, so here's what I mean by that. Okay, you can tell some of you were a little confused. If all of a sudden, in this room, if the temperature increased by 5 degrees Fahrenheit, that would be the same as it increasing by whatever 5 divided by 1.8 is. What's that? 5 divided by 2 would be 2.5. So It'd be like 2.8. So that would be the same as increasing by 2.8 degrees Celsius. That's what we mean when we say a Celsius degree is bigger than a Fahrenheit degree. It takes more Fahrenheit degrees to change to equal the same Celsius. So the point is, we are not very familiar with the metric system just because we never use it. One of our goals in this class is to get you all more familiar with the metric system. So please open your Chromebooks. I'm going to give you some questions here, and I'm going to have you research some things just about units. Because here's the thing, part of the problem is we use metric and it has no meaning to us. If I told you when I drive home, it's roughly 580 kilometers for me to drive home. I say home, I don't mean to my house in Lake Mills. I mean to where I grew up, to see my parents. It's 580 kilometers. For most of us, that has absolutely no meaning, does it? Okay? But if I told you it's 330 miles, now we can start to put that in perspective. So part of my goals for you is that whenever you hear metric measurements, that you're not totally lost thinking, well, what does that mean in miles or Fahrenheit or inches? We want it to have some meaning where that we can make sense of. All right, so tell me this. First, talk to your table partner. Which one is longer, a mile or a kilometer? Talk to your table partner. Ready, set, go. A mile or a kilometer? Which one is longer? A mile or a kilometer? Which one's longer? By show of hands, who thinks a mile is longer than a kilometer? Farther than a kilometer. So if I run a mile, I'm running farther than if I run a kilometer. Who thinks a kilometer is longer? All right, look it up. Look it up. Tell me. So look up how many miles in the kilometers in a mile, however you want to look at it. Look it up. Now, those of you that said you thought a kilometer was longer, is that because if you're going, say, 60 miles per hour, that's the same as going 100 kilometers per hour? Is that kind of, I can see some of you nodding your head there. Now, I want you to think about this, though. If the unit is bigger, should it take more or less of it to get the same distance? So picture this. If I wanted to count the steps walking across the room, if I took big steps, 1, 2, 3, 4, 5, 6, 7, roughly 8. Versus if I take small steps, which one's going to take me more? Small steps. 1, 2, 3, 4, 5, 6. I'll stop. It was going to take me a lot. So remember this, a bigger unit is going to take a smaller amount of it, okay? So if you were thinking, well, 60 miles per hour is like driving 100 kilometers per hour, they're the same speed, which one's farther, 60 miles or 100 kilometers? Well, they'd be the same. 60 miles would be the same as 100 kilometers, right? Which bigger, a mile or a kilometer? A mile. A mile is bigger because it doesn't take as many of them. Okay? If you were to drive your car from Lake Mills to Forest City, how many miles is it?
15.
Roughly 15. How many kilometers is it? It's about 25. Because a kilometer is shorter, so it takes more of them. Does that make sense when we look at it that way? Okay, again, it's like me taking short steps walking across the room. Okay, the smaller the steps I take, the more it takes. Alright, so tell me, those of you that have looked it up, what is the relationship between miles and kilometers? How many of one equals how many of the other? Morgan?
1 mile equals 1.60934.
It's roughly 1 mile is 1.6 kilometers, roughly. Okay, roughly 1 mile for 1.6 kilometers. How many cross-country folks we have in here? We got Becca and who else? Anyone else? How far do you run your cross-country meet, Becca? A 5K, which is 5 kilometers. How many miles is that, you know?
3.1.
3.1 miles. It's 3.1 miles. Again, it's more kilometers because a kilometer is shorter. Okay, 1 kilometer is shorter than 1 mile. All right. Talk to your table partner. Which is longer, 1 inch or 1 centimeter? Top. All right, by show of hands, who says an inch is longer than a centimeter? By show of hands, who says a centimeter is longer than an inch? All right. How many of one is in the other? Look it up. How many of one is in the other? Miss Nelson, what is an M? 1 inch is 2.54 centimeters, and that is exact. There are exactly 2.54 centimeters in 1 inch. So roughly 2.5. Okay? You want to make it easy. Roughly 2.5 centimeters in an inch. All right. What about this? Meters versus yards. Which one is longer? Who votes for, don't look it up yet, I want to get your instincts. Who votes a meter is longer than a yard? Meter is longer than a yard. Who votes a yard is longer than a meter? Look it up. Tell me how many meters are in a yard or vice versa.
1 meter is 30 meters.
No, it's not. It is not. Miss Rice, what did you find, ma'am?
0.9144.
But that's meters in a yard or yards in a meter.
Meters in a yard.
So think about that. If there are we'd say 0.9.
0.9144.
0.9144 meters equal to 1 yard. Which one is longer, 1 meter or 1 yard? Think about that. So what Joey's telling us, here's what she's telling us. She's telling us 1 yard equals 0.9144 meters. So which one is longer, 1 meter or 1 yard? Who votes meters are longer? Who votes yards are longer? Meters are longer. You think about this. If I have 1 yard, that is the same, the exact same, well not exact, but it's close. That is the same as 0.91 meters, which is less than 1, right? But if I have 1 whole meter, that would be longer than 1 yard then, okay? A meter is very roughly 39 inches. It's 39 point, there you go. It's about, and again, even that is not exact, okay? That is not exact. 1 meter is roughly 39 inches. And how many inches would be in 1 yard? It would be 36 in 1 yard, because there's 12 inches in a foot and 3 feet in the yard. So a meter is roughly 39 inches. Which reminds me of a funny story. Before I was coaching high school football here in Lake Mills, I coached middle school, and I'd go to all the high school games, and I'd hang out on the sideline, not like with the coaches or anything like that. With Mr. Mankey takes stats and some other former teachers that used to be here. And often, at the time, the graphic had a sports reporter that would come to the games. And I once convinced the sports reporter that the field we were playing on was marked in meters, not in yards. I convinced the sports reporter that we were playing on a field that was 100 meters long and not 100 yards long.
He actually believed it?
Yes.
Good sports reporter.
He wasn't the sharpest tool in the shed. But yes. That would be a big difference. That would be a big difference.
That's all. Yeah.
Yes.
3 more inches per yard.
Per meter.
Per meter, yeah.
It would be about 10 yards long. It would be about 10 yards long to put it in the field. Yeah. Anyway, okay. What about this? Which one is larger? Let's go with a gram or a pound. Which one is larger? By show of hands, how many do you think 1 gram is larger? By show of hands. How many do you think 1 pound is larger? But figure it out. How many of one or the other? 1 gram or 1 pound? tell me, how much larger is the pound? Tiara.
400,553.592 grams.
So, how much larger is a pound compared to a gram? 450 some times bigger, right? So, to put this in perspective, 1 gram is roughly the mass of 2 or 3, depending on the size, very roughly the mass of 3 paper clips. That's about 1 gram. Not very much, is it? Okay, not very much. What would be a better unit than the gram to compare to the pound? That would be more similar in size to the pound. Here. The kilogram. Does anyone know what the prefix kilo means?
1.
Kilo. Kilo means, here, 1,000. Kilo means 1,000. So in a kilogram, how many grams are there? There would be 1,000 grams. This is actually one of the things that you'll be watching on tonight's video that you'll be learning about. Is these metric prefixes. So a kilogram is a better unit to compare to a pound. Actually, did you know that a kilogram and a pound do not measure the same thing? What I mean by that is this, and again, you'll learn about this in the video. What quantity are you measuring if you're measuring something in kilograms? What are you measuring about the object if you're measuring something in kilograms? Any thoughts there? What do we think? Yeah.
How many thousands of grams it has?
Pardon?
How many thousand grams it has?
Yes, you're measuring in thousands of grams. What I'm asking though is what quantity are you measuring? Like for example, if I measure something in centimeters, I'm measuring its length. Length is the quantity. What am I measuring if I'm measuring something in kilograms? Here.
The area.
No. That would be like centimeters squared. Kilograms. Any other thoughts? Any other thoughts? Here.
A body?
Pardon?
A body?
I'm not asking what specific object I'm measuring. I'm asking what quantity. So again, I'll give you the example. If I measure something in centimeters, I'm measuring a length, right? It could be the length of the table, it could be the height of a person, it could be the length of your pencil. If I measure something in centimeters. What if I use it kilograms? Alexis?
Weight?
It's actually not. I figured a lot of you would say that, which is why I wanted to bring it up. Donnie.
Is it the mass?
It is mass. Gram and kilogram are units of mass. How much matter is in something? If we are measuring something with pounds, we're actually measuring its weight. They are different things. Mass and weight are not the same thing. They're not the same thing. Now that's not really the point of our discussion here. But they are not the same thing. They're related, but they are not the same thing. All right. So just to summarize here, you have a video to watch for tomorrow. Where will you find that posted? It's listed on the calendar as your homework, but you'll find it linked on Classroom. It's actually not there at this very second. I just recorded the video earlier and it was finished. I had to process on PowerPoint, so I will be getting that posted here just real shortly. So if you look in the next 12 seconds, it's not going to be there. I have to get it posted to YouTube. And it doesn't take long to upload. So watch that for tomorrow. When you get here tomorrow, some of you I'm going to give you some more help and practice on the mathematical models, graphical models, that sort of thing. If you're pretty good with that, okay, then I'm going to have you work on some of this unit stuff that you guys are going to be learning about. All right. Any questions, comments, concerns, complaints, criticisms, compliments? None. All right. So, no volleyball game tonight, eh?
Nope, not for 2 weeks.
So, hopefully that's not the case.